Okay, ladies and gentlemen, here we are with the 2018 AP number 6 question for tonight. There's going to be one like this on pretty much all the AP exams. So let's get started. Consider the differential equation dy dx equals 1/3 x parentheses y minus 2 squared. So already I probably know there's going to be a slope field somewhere along the line. There's also going to be a probably solve the differential equation problem, and we will go from there. Okay, slope field for the given differential is shown below. Sketch the solutions to the curve that passes through the point 0, 2, and the one that passes through the point 1, 0. So they make a mistake here. I'm going to go to the point 0, 2. So over 0, up 1, 2. Should I start my curve there? No, no, no. You got to check the scale of the graph as you're going, and you will see that 0, 2 is right here. And so the path it's going to follow, I have to go both forward and backward. It's going to go like that. It's sort of going to stay between the two lines. Now the next one we're going to do is the graph of 1, 0. So I'm going to find the point 1, 0, which they marked for me. And remember, it's like the trains on Wakanda, it just sort of stays between the magnetic fields. Not one is perfect. You can use slightly different from mine, but it goes something like that. But I have to remember to go in the other way as well. You've got to go both directions for full credit. And it looks like to me, it's curving and goes from there. So there is my slope field for the given differential equation. Okay, part B, just another page. There's my differential equation. They say let y equal f of x be a particular solution for the differential equation with an initial condition of f of 1 equals 0. This is important information to start with because here's what I know. I know there's going to be I'm going to need a point at some point. The point I'm going to use is 1, 0. And I know that if y equals f of x, there's other relationships that are going to be true. That y prime equals f prime of x, or dy dx equals f prime of x. That information is going to come into play probably as the problem goes on. It says write an equation for a line tangent to the graph of y equals f of x at f equals 1. So they want a tangent line. Does anyone remember the equation for a tangent line? Line? Tangent line. F prime of C. Forget your derivative, your cross-country team, and forget you. Please remember that C is the specific x value. This is our x value right here. So I can fill some information in. L equals f prime of 1, x minus 1, and f at 1. So all the information I need is going to be floating around back here somewhere. So let's go ahead and take a look. Well, I know what f of 1 is. F of 1 is 0. So L can be equal to, we'll put a plus 0 on there, x minus 1. So now the real thing is where is f prime of x? Whenever you're missing some info, always go right back to the start. F prime is dy dx. So if I substitute 1 into here, I should come up with an answer for it. Dy dx equals 1/3. X is 1. Oh no, I need to know what y is. Ooh, they told it to me. Y is 0. 0 minus 2, close parentheses, squared. So that value is equal to 1/3 times negative 2 squared, or 1/2. 1/3 times negative 2 squared equals 4 over 3. So the slope of the line is 4 over 3. And they asked me to use that information to approximate f of 0.7. Well, f of 0.7 is approximately L of 0.7, which is equal to 4/3, 0.7 minus 1 plus 0. Do I need the plus 0 on there? No. I just put it there. You can stop here. You don't have to go any farther than this on a non-calculator question. If you feel the need to go farther, make sure you don't mess up. 0.7 equals 4/3 times negative 0.3. We're going to leave it like that. We're not going to go any farther from there. Okay, so the first part of the question had us do a slope field. The next thing said find a tangent line, which we found the tangent line. And the third part says find the solution for the differential equation dy over dx equals 1/3 x y minus 2 squared. One of the techniques I'm going to be using when I solve this differential, which is obviously separate, integrate, and then solve, is when I move things around. Please remember that if I had x to the 5th, y to the 3rd equals z to the 4th, I can move things from side to side by switching the sign of their exponent. Y to the 3rd equals z to the 4th times x to the negative 5th. That comes in very handy when working on problems like this, but we're going to get ready to go and integrate this one, separate, integrate, and solve. So the first thing I'm going to do is multiply both sides by dx. dy equals 1/3 x, y minus 2 squared dx. Okay, I'm going to get all the y's and dy's on one side. This needs to go to the other side. Because everything's multiplied, I'm just going to move it. It's going to be y minus 2 to the negative 2 dy equals 1/3 x dx. That's a technique they want you to use a lot. The only time I don't do it is if this becomes a minus 1. Then I write it on the bottom because I know it's going to be an ln problem. I've now separated the x's, dx's from the y's and dy's. I can now integrate. So the integral of this, integral of something to the negative 2, something to the negative 1, negative sign on the outside, equals 2/3, oop, nope, sorry about that, 1/6 x squared plus c. Where did I get the 1/6 x squared? The integral of this is 1/3 times 1/2 x squared. That's why that works out, okay? Now I have to get y by itself. So I'm going to multiply both sides by negative first. Plus that out. So I've got y minus 2 to the negative 1 equals negative 1/6 x squared plus c. You want to put a minus sign on there? Feel free. You can choose to or not. Okay, I got to get that negative 1 power away. So I'm going to negative 1 both sides here. So y minus 2, cancel, equals negative 1/6 x squared plus c to the negative first. Now I'm going to get y by itself, so I'm going to add 2 to both sides. And there's my particular solution. Sorry, my general solution. Now to find the specific solution, to find the c, I've got to substitute in the f of 1 equals 0. That's a 1. So 1 is my x, 0 is my y. I'm going to substitute them in. 0 equals parentheses, negative 1/6. X is 1, so that plus c to the negative 1 plus 2. Now my job is to solve for c and then write the equation with the c in it. Remember, once again, I'm going to undo what I did here for a second. This right now is my general solution. Let's write it all the same. So I stuck in the 0 and the 1. And now I'm going to try to solve away. I'm going to subtract 2 from each side. Negative 2 equals negative 1/6 plus c to the negative 1. Okay, got to get rid of that negative 1 power. So I'm going to negative 1 both sides. So I'm not even going to simplify this one. I'm going to do this 2 different ways. I'm going to show you. So I've got negative 2 in parentheses to the negative 1 equals negative 1/6 plus c. And add 1/6 to both sides. So I know that c is equal to negative 2 to the negative 1 plus 1/6. If you didn't want to change that format, you can totally leave it like that and fill that in for c in the answer. I'm going to find it as a number. I'll write it both ways. C equals, well, negative 2 to the negative 1 power is negative 1/2. We just flip it. Plus 1/6 equals 3/6. Negative 3/6 plus 1/6. So I'm going to get negative 2/6. Didn't want to do that step. That's absolutely fine. You don't have to. So now in writing out the solution, I'm going to erase over here for a second so I can finish the problem. You normally write this on another page. I know what c is. Y equals negative 1/6 x squared plus negative 2/6 to the negative first plus 2. You can write the answer like that, or you can write it as y equals x squared plus, in parentheses, -2, -1st, plus 1/6. Either answer is correct. If you don't feel like filling out the whole constant, this is what it's equal to. You can write that whole thing in right there. Okay, there's our video. Have a good night.